Welcome to Study Loop.
Problem 7.33. So we've got this box moving around in the xy plane. It has a given mass. And in the xy plane, there's a force acting on it that has an associated potential energy function of alpha x squared minus beta y squared, where alpha and beta are what I've put in here for the sake of convenience for these constants they've given us. And we want to find the magnitude and direction of the acceleration of the block at this xy position. So, to start, we know the x component of the force is the partial derivative with respect to x, the negative of the partial derivative. The y component of the force is the same, but for y, it's the y derivative. And we know since this is the only force acting on it, it's the net force. And so that the acceleration is going to equal force divided by the mass. So let's get started taking some derivatives here. F sub x will be negative times the derivative with respect to x of this. This has no x dependence, so it's 0, or its x derivative is 0. And then we'll have a 2 alpha x here. With a negative sign. The y component, we already have a negative sign here, so this will have a positive sign. And this will similarly be 2 beta y. The y derivative of this is 0. So everything is looking good so far. So yes, now we know that the x acceleration and the y accelerations are the respective components of the force divided by the mass of our block. And if we evaluate these at the point of interest, we get negative 87 meters per second squared here for x. And for y, we get 97.2 meters per second squared. So here's the acceleration as a vector. Its magnitude, of course, comes from the Pythagorean theorem. So it has a magnitude of 130 meters per second squared. And then its direction, which we can call theta, is going to be the arctangent of the y component divided by the x component. And so because x is negative, this ends up being 132 degrees in the normal sort of counterclockwise from the positive x direction. Depending on the implementation of the arctangent function you have on like a calculator or on a computer, you may have to do a little bit of thinking, because the arctangent of this without the negative sign is 48.2 degrees. But that'll be from the negative x direction, because it's this vector has a negative x component and a positive y component, which if we move it to where it's like we're adding them, you know, this is going to be the angle from the x direction, so the negative x direction. So it has to be subtracted from 180 degrees. So that's just something to be mindful of, is that the way arctangent is normally defined, it doesn't give you an angle that, it doesn't always give you the angle that's in the 360 degrees around starting from the positive x direction. Because if you think about it, if one of them is negative and it's just based on the division here, it can't tell which one is negative. And similarly, if they're both negative, then it can't tell the difference between the first quadrant here and the third quadrant here, because the two negatives here will cancel out to make it look like it's in here. So that's just a little thing to be aware of with arctangent. In some computer programming languages that you can use for doing, they basically use them as a calculator. There's a function called arctan2 or atan2 or something. And instead of taking the ratio of these directly, it takes both x and y and then figures out for you what quadrant it goes in.